Welcome guys. So today we're going to have an introduction on trigonometric identities. Then we'll also have to, if we have enough time, we're also going to introduce trigonometric equations here. Okay, so a trigonometric identity is just a relationship that is true for all values of the unknown variable there. Okay, so you can just put this in writing. So saying a trigonometric identity is a relationship that is true for all values of the unknown variable here. Like this here. Okay, so for this topic we'll have to master, or you have to know or memorize the trigonometric identities there. So we'll start with the basic ones. Of course, there are double angle identities, sum of angle identities, half angle identities, others. So as we go on, you get to know what double angle identities are, what sum of angles of identities look like, and so on and so forth. So, okay, so let's look at the basic trigonometric identities here. So I'm going to say basic trig identities. So for basic trigonometric identities, one here, we have if you divide a sine function, so let's say sine theta here, divided by cos theta, it's going to give you a tangent function here. So we're going to get tan theta like this. Then 2 here, if you divide a cosine function, so cos theta here, divided by a sine function theta here, you get cot theta like this here. Then at the same time here, okay, so that is 2 here. So 3, we say if you divide 1 by sine theta like this, you get cosec theta like that there. Then 4 here, if you divide 1 by cos theta, you're going to get sec theta like this here. Then if you have a right angle triangle, so I'll just include one of these here. So if you have a right angle triangle there, okay, so if you have a right angle triangle, then you are asked to find the sine function, the tangent function, and the cosine function. We can just use what we call as the SOHCAHTOA. Okay, so what do we mean here? For a right angle triangle here, so for SOHCAHTOA here, so first things first, here for the sine function here of a right angle triangle, meaning the sine theta here is simply equal to the opposite of the angle that you are looking at there over the hypotenuse, which is the longest side of the triangle that you have, of the right angle triangle that you have there. Then cos theta here is simply equal to the adjacent, which is the base, so the adjacent over the hypotenuse like this here. Then for tan theta here is simply equal to the opposite over the hypotenuse like this here. Okay, so let's add one more, the Pythagorean identity there. So the Pythagorean identity here, so we have so that should be number 6 like this here. So the Pythagorean identity here, if you say sine squared theta plus cos squared theta, gives us 1 like this here. So from this Pythagorean identity that we have here, we can derive 2 more identities here. So let's say identity number 7, that we can get from there. So from this here, if we say, let's divide throughout this expression that we have by sine squared theta here. So we have sine squared theta plus here again sine squared theta, even this side sine squared theta like this here. Now remember, when we started here on top here, let me just scroll up a bit. Okay, remember I said if you divide a cosine function with a sine function, you get a cotangent function here. So meaning that here, sine squared theta divided by sine squared theta, we're going to have 1 plus here cos squared theta divided by sine squared theta. Remember, if you divide a cosine function with a sine function, you get a cotangent function here. So meaning that this is going to be, since these functions that we're dividing are squared, so this becomes cot squared theta equal to, then if you divide 1 by a cosine function, we said if you divide 1 by a sine function, we said we get a cosec function here. So we get a cosecant there, so meaning that here we're going to have a cos sec squared theta like this. So this is another identity that we have that you need to master there, or that you need to memorize. Okay, so let's add one more here. So let's say number 8 here. Now if we decide to say, let's divide now throughout with a cosine function. Remember, we divided with a sine function. So let's divide throughout with a cosine function here. We divide the equation number 6, or identity number 6, with a cosine function. So here we have cos squared theta, cos squared theta, and cos squared theta like this. Now here, when you divide the sine function with a cosine function, you get a tangent function. So since these two functions that we have here are squared, we're going to have tan squared theta plus, if you divide a cosine function with a cosine function, you're just simply going to get 1 there. So equal to, now if you divide a cosine function here, if you divide 1 by a cosine function, you get a second function there. So mean that here we're going to get a sec squared theta like this here. Okay, so these are some of the basic trigonometric identities that we have there. But then I'll advise you to download this document on the internet, which is the trig function. Okay, so you download the trig sheet. So just say you download the trig sheet here. It's going to bring you all the trigonometric identities that you have to know there. So for today, these are the only ones that we're going to work with there. Okay, so now let's look at examples where we can apply this information that we have here. So simplify. Following trigonometric functions. So 1, okay, let me scroll up a bit. Okay, so the first one that we have here is let's say we're told to say we need to simplify sine squared theta, cot theta, and sec theta like this here. So now, if you're told to simplify this here, you first look at the expression that you're given and you identify identities in there, or where you can make trigonometric identity substitutions there. So if you look at this function that we have here, or this trigonometric identity or function that we have here, you notice to say that this cotangent function here, so let me use a different color for this. So you notice that you have a cotangent function here and you have a second function like this here. These two here are identities here. Remember now, you have that since you have 1 over, okay, so this can be 1 over, so for sec here, since you have 1 over cos theta is equal to sec theta like this here. Then the other thing here, you have that since you know that sine theta, or cos theta rather, divided by sine theta like this gives you cot theta like this here. If this is the case here, then where you have sec theta and cot theta in this expression here, you make a substitution with the identities that you have this side here. So meaning that here we're going to have sine squared theta, open brackets, where there's cot theta, we put the identity for cot theta, which is cos theta over sine theta here. So we have cos theta divided by sine theta like this here. Again here, open brackets. For sec theta here, we know that it's 1 over cos, so we do the same thing here. We have 1 over cos theta like this here. Now, here, looking at this here, you notice that there are things that can easily be cancelled out in this case here. So we have a cosine function here that can cancel out with a cosine function there. Then this sine squared here simply means that, or let me just write it like this. So sine squared theta here simply means that we are multiplying this sine function by itself 2 times. So meaning that here we can have sine theta like this multiplied by sine theta there. So since cos and cos have been cancelled out already, so that's just 1 there divided by a sine theta that we have below here. So meaning that a single sine function can cancel out with 1 sine function on top there. So I mean that when you simplify that expression, the answer that we're supposed to get is just going to be sine theta like this here. So this becomes the simplified version of, or this is supposed to be the solution when you simplify this trigonometric expression that you have on top there. Okay, let's look at the second one. So the second one is an identity here, so we're going to say prove the identity. So here we're going to do here, so prove that tan x plus sec x divided by sec x 1 plus tan x over sec x like this is equal to 1. Okay, so now here, there's one thing that we need to note here when you're proving trigonometric identities. So our goal here is that we need to simplify the left hand side until it looks like the right hand side, this side here. So we need to show that the left hand side is equal to the right hand side here. So like I mentioned earlier on, when you're given a trigonometric identity that you have to simplify, or that you have to prove that the 2 sides of the expression that you're given are equal, then you first have to identify the identities that are involved, or the identities that are found in the expression that you're given. So if you look at this here, on the left hand side here we have tan x here, so meaning that tan x is an identity there, and we have sec x as an identity there. So we just have the second function and the tangent function that we have on the left hand side here. So meaning that here, let me scroll down a bit. Okay, so we need to identify the identities that we have in that case there. So the identity that we have there, we're saying we have a tangent function and we have a second function here. So here we can just say our solution there. So we need to show that the left hand side is equal to the right hand side here. So meaning that when we simplify the left hand side, we should be able to get to the right hand side, which is just a 1 this side. Okay, so now here, since tan x is made over sine x over cos x, or divided by cos x, then we also know that sec x is equal to 1 over cos x like this here. So just go ahead and make substitutions in this expression here, then we start simplifying here. So we're working out the left hand side to show that it's equal to the right hand side here. So let me use a different marker for that. I'll use black. Okay, so for the left hand side here, like this here. So I'll change how this is written. So I'll write first the numerator like this in brackets. So we have tan x plus sec x divided by, so here we have open brackets, sec x 1 plus tan x divided by sec x, like this here, like that there. Now here we can just go ahead and substitute the expressions that we have in that case there. So on the numerator there we have, for tan we said it's made up of sin x over cos x, so we have sin x divided by cos x, like this here, plus then sec x here is just 1 over cos x there. We close there, divided by here. They said let's make this a single fraction first. So if we multiply here, if we multiply by sec x throughout, we're going to get sec x plus tan x. Like this here. Okay, so I go ahead and try to simplify everything that we have there. So on the numerator here we have sin x divided by cos x plus 1 over cos x divided by, then this side, that is 1 over cos x. So that's a second function there, so that is 1 over cos x plus sin x over cos x. Like this here. So now we make this, we make the numerator there a single fraction. We also make the denominator this side a single fraction here. So now if you check on the numerator here, our common denominator here is just simply cos x here. So we're going to have cos x like this, then cos x into cos x we get 1 multiplied by sin x, here we get sin x like this, plus cos x into cos x 1 multiplied by sin x here, or 1 multiplied by 1 there, we get 1 like this. We close here, we multiply by, we divide, we're still dividing there, so let me just erase that. Okay, so we divide by, even this side we have cos x as the common denominator there, cos x into cos x we get 1 multiplied by 1 there, we have 1 like this, plus cos x into cos x we get 1 by sin x, we get sin x like this here. Now remember, when you're dividing two things here, if you have, let's say a over b divided by c over d like this here, for you to change this division symbol that we have on the middle there into multiplication, you need to take the denominator becomes the numerator and the numerator becomes the denominator on the right hand side here. So meaning that this is the same as a over b multiplied by d over c like this here. So we do the same thing with the expression that we have below there. So meaning that here we have sin x plus 1 divided by cos x will be multiplied by, then this becomes the numerator there, and this expression becomes the denominator there. So meaning that this becomes cos x divided by 1 plus sin x like this here. Okay, so now here you notice to say that if you multiply the two here, you're simply going to have cos x open brackets sin x plus 1 divided by cos x sin x plus 1 like this. So what you have on top, cos x and cancel, 1 plus sin x and 1 plus sin x will cancel there. So I just left with 1 there. So meaning that here you have proved that the left hand side here is equal to the right hand side like this. So we've shown to say that this expression that we have there, or the trig identity that we have on top there, is indeed true there, because we've shown to say that if you simplify this, we're going to get the right hand side, this side, which is just 1 there. Okay, so let's look at another example. So let's name it 3 here. Okay, so prove that prove that 1 plus cot theta divided by 1 plus tan theta is equal to cot theta like this here. So as usual here, our goal here is to show that the left hand side here is equal to the right hand side like this here. So what this simply means here is that we have to simplify the left hand side until we get something that looks like what we have on the right hand side here. Now, first things first, we need to identify the trig identities that we have in this case here. So the identities that we have here, we have cot theta here. So here we're going to say, since cot theta is equal to 1 over tan theta, which is the same as cos theta over sin theta like this here. And also we have tan theta here. Okay, so we have tan theta here. So tan theta, we know to say that this is made of sin theta over cos theta like this here. So we can go ahead and substitute into the expression that we have there. So I'll just try to do this instead of going to the next page there. Okay, so I can work out the left hand side first, this side. So here, the numerator there, we have 1 plus tan theta like this here, divided by, or 1 plus cot theta, sorry. So that's cot theta on the numerator. So 1 plus cot theta divided by 1 plus tan theta like this here. So here, we substitute with the identities that we have here. So meaning that this is going to be 1 plus. So for cot theta here, remember we said cot theta is just the same as 1 over sin, cos theta over sin theta here. So meaning that that's 1. So cos theta over sin theta like this here, divided by, this side we have 1 plus. So for tan theta here, that's sin theta like this over cos theta there, like that. So this will be equal to, now we make on top here we make this a single fraction. So our common denominator here is just sin theta here. So we have sin theta like this. Okay, so 1 into sin theta, we get sin theta. Sin theta by 1 here, we're going to get sin theta then. Like this here, plus, then here, cos into cos theta, or sin into sin theta, we get 1. 1 by cos theta, we're going to get cos theta like this here. We close here, plus, or here we're dividing, we make this, that's on the denominator here, a single fraction. So here we're going to have cos theta as the common denominator this side. Then this here is the same as over 1. So it's the same thing even this side. So 1 into cos theta, we get cos theta by 1. We're going to get cos theta there. Plus, cos theta into cos theta, we get 1. 1 by sin theta, we get sin theta like this here. Okay. So let me scroll down a bit. Okay. So now, here, we have that sin theta plus cos theta divided by sin theta I'll just write this again here. So we have a cos theta plus sin theta over cos theta like this. So now our goal here is when we change this division symbol here into multiplication here, the denominator becomes the numerator here, and the numerator becomes the denominator there. So meaning that here we have sin theta plus cos theta divided by sin theta here, multiplied by cos theta divided by sin theta plus cos theta like this. Now here, if we multiply all these that we have here, we're simply going to have the following here. So here we're going to have cos theta, open brackets, okay, so cos theta, open brackets, sin theta plus cos theta here, divided by sin theta. If we multiply it with what we have below there, we're going to have sin theta plus cos theta like this here. So sin theta plus cos theta can cancel out with sin theta plus cos theta here. Then we're just left with cos theta over sin theta. So we're just left with cos theta over sin theta like this. Now remember, cos theta over sin theta gives us an identity here. So meaning that this identity here is just simply cot theta here. So here we're going to have cot theta like this here. So if you look at the question that you have, we've shown to say that the left hand side is equal to the right hand side, because this cot theta that we have is what is on the right hand side, this side here. So therefore we've shown that 1 plus cot theta over 1 plus tan theta is simply equal to cot theta like this here. Okay, let's look at the next example. So we're going to do as many examples as possible until we get a bit comfortable with this. Or we're just going to do a few more examples, then we get a bit comfortable with that. Okay, so this should be example number 4. So we have to show that cos squared theta minus sin squared theta is equal to 1 minus sin squared theta like this. So we need to show that is equal to 1 minus 2 sin squared theta like this. Now the other thing here that I would say here is, when you're manipulating a trigonometric identity like this one here, you need to take note of the identity that you have on the right hand side there. So now here on the right hand side here, we have a sine function which is in the final expression that we need here. So meaning that whatever we're going to do here, we're supposed to be left with a sine function somewhere there. Now remember, we talked about the basic trigonometric identities that we have on top there. So there's a Pythagorean identity that we talked about there. So since here, when you look at what you have on the left hand side here, you notice to say that these two here are not identities, but they can come from some identity that we have there. So in this case, we're simply going to talk about, or we're simply going to bring the Pythagorean identity there. So the Pythagorean identity here, remember that since we said, so I'm just going to say so we have to prove that the left hand side is equal to the right hand side, this side. So here we're going to say that since we have sine squared theta plus cos squared theta gives us 1 like this here. Now we have to manipulate this in such a way that we'll have something that we're going to substitute into the left hand side, this side here. So what we're simply going to do here is that since on the right hand side we have a sine function that we need as part of the final answer this side, so meaning that we can just make this cosine function here as the subject here. So if we make the cosine function here as the subject here, we're simply going to have cos squared theta is equal to 1 minus sine squared theta like this here. Okay, so now when you start working out the left hand side now here, where there's so we have cos squared theta minus sine square theta like this. So where there's cos squared theta here, we're going to substitute with this expression that we have this side here. So meaning that here we're going to have 1 minus, okay? So we have 1 minus sine squared theta minus, we still have the sine theta here. So sine squared theta like this. So then sine squared theta and sine squared theta are the same functions, or they are like 10. So meaning that we can simply just add them together here. And they are all raised to the same power 2 here. So we can just simply add them together. So here we're going to have 1 minus 2 sine theta like this here. Okay, so we have 1 minus 2 sine squared theta like this here. So if you look at this here, this is exactly what we have on the right hand side like this here. So mean that we've proved to say that this trigonometric identity that we have here indeed holds there. Okay, so let's go to the next example here. So let's say this is example number 5 like this here. So prove that the square root of 1 minus sine x divided by 1 plus sine x is equal to tan x or sec x minus tan x like this. Okay, so we have to show that the left hand side is equal to the right hand side in this case here. Now let's look at what we have on the left hand side. So we start simplifying what we have on the left hand side here. So on the left hand side here we have the square root of 1 plus sine x divided by, or 1 minus sine x divided by 1 plus sine x like this here. Now if you notice that a trigonometric identity that you're given there has no identity that you can make a substitution with there. So what you do here is you need to try and manipulate this trigonometric identity here that you have, so that at least you're going to have an identity to substitute with there. So what we mean here is, in this case here, 1 plus sine x or 1 minus sine x is not an identity there. So what we get to do here is we get to rationalize the denominator there. So remember, rationalizing a given expression is just changing the sign that you have on the middle there. You make a fraction of itself and then you multiply it by the whole expression that you have here. So meaning that here we're simply going to rationalize the denominator here. So if you rationalize this, we're going to have so let me just close this in brackets so that it's easy for us to multiply there. So here we're going to have 1 minus sine x like this here. So we get the conjugate of the denominator here, then we make a fraction this side. So and 1 minus sine x like this here. So now don't go ahead and cancel out anything here. So what you're just supposed to do there is you start simplifying the expressions that you have that are under the root there. So here now on top here, you notice to say that this first term that we have here and the second term are just one and the same thing there. So meaning that what can we do here? We can just say this is the same thing that's being multiplied by itself twice. So we can just raise it to the power 2 here. So here we have the square root of, open brackets, 1 minus sine x like this to the power 2 like this. Divided by below here, we're going to multiply term by term below here. So 1 multiplied by 1 here, we're going to have a 1. 1 multiplied by negative sine theta, we're going to get negative sine theta here. Like this here. Then sine theta by 1, we get positive sine theta like this here. Then sine theta multiplied by negative sine theta here, we're going to get negative sine squared theta. Oh, sorry, that's x like that here. Okay. So we simplify this expression further. So simplifying this expression further here, we're going to have the square root of 1 plus, or 1 minus, sorry, so that's 1 minus there. So the square root of 1 minus sine x, like this here, squared, divided by, so negative sine x and positive sine x will just cancel themselves out there. So we're left with 1 minus sine squared x, like this here. So now, when you look at this here, you notice that we're going to have, we have a trigonometric identity that we can substitute with here. So this that we have below here comes from the Pythagorean identity that we have here. So remember that the Pythagorean identity here is, if you have sine x squared plus cos squared x, like this here, this gives you 1, like this. Now, to make an expression that looks like what we have on the denominator here, we make cos squared x the subject this side here. So meaning that here we're going to have cos squared x here is simply equal to 1 minus sine squared x, like this here. So meaning that this side here, where you have 1 minus sine squared x, which is the expression that you have here, you can substitute with cos squared x in this case here. So meaning that there, we're going to have the square root of, open brackets, 1 minus sine x squared divided by, so divided by here, we have cos squared x, which are going to substitute with what we have below here, because this here gives us cos squared x here. So divided by cos squared x, like this here. Now, remember, cos squared x, like this, is the same as cos x squared, like that there. So meaning that here, this expression here is the same as the square root of, okay, let me scroll down a bit, the square root of 1 minus sine x squared divided by cos x squared, like this. So here we can just close everything that we have here under one bracket there. So this is the same as the square root of 1 minus sine x divided by cos x, like this, and then everything raised to the power to here. So this comes from one of the properties of indices there. If you have a squared divided by b squared, this is the same as a over b squared, like this. So this power 2 and the square root that we have there, they can just cancel out. Then we're left with 1 minus sine theta, or sine x there, divided by cos x, like this. Then here, if you have a squared, or let me use the same things. If you have a squared plus b squared divided by c here, this is the same as a squared over c plus b squared over c, like this here. So we apply the same principle here on the expression that you have this side. So meaning that there, we're simply going to have 1 over cos x, like this here, minus sine x over cos x, like this. If you make this a single fraction, it will take you back to the initial stage that we have there. So now, again here, these two fractions that we have here, they give us an identity here. So remember now, since sine x, or since we have 1 over cos x gives us sec x, like this here, then sine x over cos x gives us tan x, like this. Then we substitute into these two fractions that we have there by the identities that we have this side here. So I mean that 1 over cos x here will just give us sec x minus sine x over cos x here, which simply get tan x, like this here. So we've shown to say that the left hand side is equal to the right hand side this side here. Okay, so I'll give you questions to simplify here. So question number 1 here. So So an easy one here, just show that. So prove that sin x cot x is equal to cos x, like this. Then the second one, we need to show that cos x minus cos cubed x divided by sin x is equal to sin x cos x, like this. Then the third one, we have to show that 1 over the square root of 1 minus cos squared x is simply equal to cosec, or 1 minus cos squared theta is simply equal to cosec theta here, like that there. Alright, thank you. We'll look at trigonometric equations in the next lesson there.